important part of games is the use of data. There's a lot of data going on around in the game, outside the game, that is important to be able to manage properly. So let's see a few examples of how to control this data. One of the questions is how do you manage data between different scenes? So when you move from one scene, let's say level 1 of your game to level 2 of your game, and you're going to continue carrying data from one to another, how do you actually load it? Well, there is this strat called player prefs, which essentially is a hash map that Unity holds that allows you to store data, and those are always available. Those, you can, in any point in the game, you can access this player prefs hash map and load data you have. So essentially you have different values, like you have a string that gives you a key, in my case, I don't know, player health, and you basically have a value for that, a float value or an integer value. It could be another string value. There are some other values as well. So you can get these values and set these values, like having a storage place when you put variables, and you can access them at any time. However, this is a place where you shouldn't be saving things and loading data between scenes, or even when you're doing a save game from a game for a game itself, when you want to just quit the game and continue playing another day. How do you recover that data? Essentially, player prefs is not a place to do it, because player prefs is saving all this information in um, plain text, right? So when you actually write something here, that's going to be saved in a text file. And in fact, Unity by itself saves the information that is in player prefs, even if you don't do it manually. When you actually quit the application, automatically Unity saves that into a file, into a text file. Okay. And the problem with that is that obviously if you have information that is sensitive, like the level in which the agent or the player is, that essentially means is that people could very easily cheat. You could basically go there, change the text file, and then jump a few levels ahead, right? Here's some examples of how to set and get information from these player prefs. And then essentially you can also check this information, the script reference, which among other things also tells you where in your operating system, because that changes if you're using Mac or Windows or Linux, which is the location where these save files are stored in your computer. But yeah, as I was saying, player prefs is saving this in plain text, so it's not a very secure way of saving this information. So not surprisingly, player prefs should be used to actually save player preferences. So what you mean with player preferences is what you can understand as things that you could set in your game, like for instance settings of the games. So the preferred volume, the preferred resolution, sound effects, if you want to be active or inactive, or maybe if you want to have subtitles with the videos or the sound in the game. So all this information that is not critical for the actual progress in the game should always be saved in the player preferences. And it doesn't really matter if the user finds this text file and modifies it externally, because that's not going to be a way of cheating in the game, right? So if player prefs is not a place to put it, where can you do that? Well, one very simple way of doing it is to save this data in an object. So essentially, you just put the object information there, you save the data in the object, and the objective then is to avoid destroying that object. So when a scene is removed, when you get out of a scene, when you close a scene in Unity, all the objects that are form part of that scene are destroyed, and that destroys all the objects and obviously all the objects in the hierarchy. However, you can use this function called don't_destroy_don't_load, which essentially what it do is saving that object for being destroyed when loading a new scene. Okay, and it doesn't only save that object, it also saves all the objects, game objects that are in the hierarchy, and also the components that are associated with those objects. So essentially, you can have an object that you can move from one scene to another, and then that object could have the information that you require. A very simple way of making this happen would be to have this simple script, and I really mean simple because it's only 5 lines, which is called don't destroy, right? And then in the awake function, it just calls this function don't destroy on load with the own game object that owns this script. So once you have this script in your game, essentially the only thing that you have to do is when you have this game object that you want to keep consistent between different scenes, then you associate this component, you add this component to this game object, and automatically that game object is not going to be destroyed. It's a very simple way of keeping objects between scenes. And then obviously this object can be used for keeping that data that you want to control from one scene to another one, from one level to another one. Okay, so you could have here, for instance, public in health, and you might have this game control object is the one that you are actually saving. So you are basically making sure that this is not destroyed, and then you can just save this health over here, right? And that is going to be maintained from one scene to another without needing to write in files or finding other esoteric ways of keeping the health. Okay. And of course, you might have many other variables here that you want to keep. Now, at some point, you will like to actually save this into a file because you don't expect your player to play the game from the beginning to the end, right? And then we're going back to the same problem as before. You wouldn't want to save this as a text file because that is subject to cheating. So the idea would be to basically save an object file, which this is done through serialization. You might be familiarized with the term, but essentially it means that it converts an object that is in memory into a stream of bytes, right? So that is normally, you can take that stream of bytes and put it into memory, put into a database, or what we're interested here is to be put into a file. So you might have essentially a file object, and it's an object, it's a file that you can open, but it's not human readable. You could see essentially a lot of Unicode characters that are actually not modifiable. And if you try to modify that, probably what you do is you corrupt the file, and that file won't be able to be saved again. So in Unity, it's actually quite simple to make an object serializable. And the only thing that you have to do is to include this tag at the top of the class. So you have a class player data that contains the health. You might have this tag over here at the beginning that says serializable. And that allows you that if you save this object, if you add these load and save functions, then you can save this object to file directly, and the whole object could be saved and put into a file in a way that a human couldn't read. Okay, so imagine that you have a data class that contains all the information that you want to keep from one scene to the next. You might have all that information there very nicely stored, and you can also add the load and the save functions that allow you to save into file for whenever you actually have to stop executing the game and then continue later on in another execution of the program. So how would this look like? So you might have a script that looks like this. So you have your player data. In this case, this is a private class that has this variable called health, and you might have many others, of course, here, but it's a class that it only contains data. It's a data class, right? And then you have this game control object. That is the one that holds the information. So you might have maybe a reference to this player data, or you might have ways of loading and saving into this object player data. But you have the information here. You don't want to destroy it on load, and then you add two different functions, right? The save function and load function. So how does the save function look like? This is basically using C# to save into binary format. So you just essentially specify which is the file name where you want to save, and that could be somewhere where you define to save these save games. You can you then create a binary formatter in order to file to save the file in a binary format, and then you open this file in order to create, right? As we can see here, it's creating this object called player data, and it sets the player data health with the data that was created before, right? So this health over here is using the game control, and when you want to save it, you just dump this value into a player data object, right? So the player data object itself is just going to contain that health value over here, And then we just call serialize, which is a function in this binary formatter class. And then that writes this player data, the object player data, into the file that you have specified over here, the one that you open with this file name. And then you have to close at the end. Once this has been written into the file, you close the file, and that saves the file in the actual disk in your computer, right? Analogously, you can have also the load function, which essentially does the opposite. As you can imagine, just identify the file name path. Then if that exists, open the file in open mode, and then deserialize the object. And see that here you have the binary formatter again, have the function called deserialize, where you pass the file object, and then that returns an object that needs to be cast to the player data. Okay. And then you can just close this file, and then you can read from that player data. Once you have read this, you can just load the information from this object into the variables that you have in this script, right? So of course, having this script and this object, you can access this game control object from anywhere in the game. So when you need to save or you load, you just basically access the script, colon save, colon load, and then you do these operations. Okay. One important thing to consider is that because you are saving and loading objects, if you save an object that has, for instance, one parameter only, health, and then in future developments you add another parameter here that could be, I don't know, power. That means that those files that were saved when this class only had one parameter, you won't be able to use them to load them. Essentially, when you're trying to load over here, this deserialization, it would actually not be able to cast back to player data because those are two different objects. But as long as this, when you are in a process in your development where this object is constant, this class doesn't change the parameter, the types, or the number of parameters, then this particular system of saving and loading works very well and allows you to keep consistency between one save and then when that file is being loaded later when you want to play the game again.